Hello. Today we're going to talk about kinematic equations. Kinematic equations are just basically your main equations. They're going to help you solve displacement problems. So that's your distance problem, how far away you are from something, velocity, time, acceleration. So those equations are going to have those things in them. They're not the only place you're going to find those things in them, but they're the places that they're your go-to equations. So let's go ahead and let's get those going. Alright, first equation I'm going to go over is basically the distance equation. So, or displacement. So we've got displacement equals your V naught. What V naught means, that's your starting velocity. Okay, it's multiplied times time. We're going to add that to 1/2 your acceleration times squared. Okay, this equation you're going to see quite a bit. We're going to see certain things later on. You're going to start noticing certain things. But a lot of times your starting velocity is going to be 0. And since it's multiplied by this initial time here, we can get rid of that time too. So most of the time you're going to see this equation is like a free fall equation where its distance equals 1/2 your acceleration times time squared. Okay, so even though it's written this way, most of the time you're probably not going to see it this way. Alright, next equation. Okay, it's going to be one of your velocity equations. Now this is V sub 1. V sub 1 is basically just another way of saying this is your second or your final velocity. Okay, I know even though it shows you a 1 there, that's a little confusing. That's your final. Okay, and we're going to square that. And that's going to be equal to your V sub naught, or your initial velocity squared, plus 2 times your acceleration times your displacement. Okay? Alright. Next one. We have a V sub 1 equals V sub naught plus AT. Same thing. A lot of times that V sub naught is 0 because we're starting from rest. So look for keys like that in your problems. Starting from rest. Look for, is it an object that's falling? Those are all certain things that are going to help you out when you're doing these problems. Alright, and the final one I'm going to give you here is displacement equals 1/2 of V sub 1 plus V naught multiplied by your time. I'll get out of your way for that. Okay, so those are the problems or the equations you're going to see quite a bit for kinetics, for kinematics, and you'll be using those throughout the year. So make sure you know those. We're going to have a place in the back of your book or your back of your notebook that you're going to want to write all those things down. But I'll tell you about that later on. But in your notes for right now, those are definitely equation notes. All right. So let's go ahead and let's do a couple problems with those before I send you off to do one on your own. Alright, an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. Okay, remember we're going to go by the guess method. Okay, so guess method, we're going to be looking for givens. Okay, so what does it give you in the problem? Alright, so let's go ahead and take a look to see what our givens are. And it gives us acceleration and it gives us time. Okay, it's accelerating down the runway. It gives us acceleration that's not a free fall acceleration or anything. It's actually trying to push. It's a force. So we're not going to go with that gravity acceleration. Alright. Now U is going to be units. The units it gives us to here are meters per second squared, which is a common unit. That should be our base unit for that, for acceleration. And our time is in seconds, so that's also another good one. We want to stay with that one. Okay, so units are good. E is going to be an equation. So we're going to want to set up an equation for this particular problem. Now, the things that we know we know acceleration equals 3.20 meters per second squared, and we know time equals 32.8 seconds. Alright, now what we're going to solve for is distance or displacement. Okay. Now, since we have an acceleration that's in meters, our displacement should also be meters. Okay, and that's really what our answer should be in for displacement anyways. Now, what we're going to want to do is we're going to look to see what equation we need for that. And we're going to go to our kinematic equations. Okay, so when I look at that, the only equation that really fits this is going to be D equals V sub naught T plus 1/2 AT squared. Okay, so I'm going to go ahead and substitute what I do know. Now, do I know an initial velocity? Well, the plane is at rest, so we're going to assume that that's going to be 0. So that 0 times t is going to just knock that out, so that's awesome. We get rid of that right off the bat. We're going to substitute the rest of it though, so we have 1/2 3.2. I'm going to go ahead and just eliminate the units for right now. And our t is 32.8. And that equals D. Okay, so we've done our substituting. Okay, so that's done. Now the last part of guess is to solve. So we plug that into our calculator. And if we're doing things right, we end up with 1,721 meters. Now I'm not super worried about sig figs on this right now. There's a lot of things that we can deal with, but our measurements, we're just going to kind of go with calculator answer for right now on that. We mark it as being our answer and we move on. Alright, next problem we have. We've got the great Upton Chuck. Upton Chuck is riding the great drop at Great America. If Upton free falls for 2.6 seconds, what will be his final velocity and how far will he fall? Okay, so we're still sticking with the guess method. I'm not going to go over everything again on this one, but I am going to go and we're going to find our givens. In our givens, we have what just appears to be 2.6 seconds. Okay, so we have a time equal to 2.6 seconds. What's not shown there, though, is we also have an acceleration equal to 9.8 meters per second squared. Now, we'll use different numbers for acceleration through the class, at least for Earth. You might hear 9.8, you might hear 9.81. There's sometimes we'll just use this to flat out 10 just to make the problem really, really quick and the math really easy. But we'll be all over the place on that, so I'm going to use 9.8 on this one. Okay, we also have an initial velocity, so V naught is equal to 0. So I'm going to go ahead and write that down on this one. Okay. Now our units, we have seconds, we have meters per second squared, and we have meters per second. Those are all great base units that we want to be in. Okay, so units are good. We're going to go to an equation. So if we look through equations, we actually have to look at not one equation, but we have to solve for final velocity and displacement. Okay, so let's go ahead and see if we can solve for final velocity first. Sometimes you're going to have to solve for one and then the other. So let's see if we actually can get both of them just right off the bat with just the first one. So we're going to solve for final velocity, or V1. So if I look through my equations and I see what I have out there, I'll see that one of my equations is V sub 1 equals V naught plus AT. Okay, I can do my substituting. My substituting for that one is going to be V sub 1, because I don't know that, that's what I'm solving for, equals 0, so I'm not even going to write that in, and then 9.8 for my acceleration times the time of 2.6 seconds. Handy dandy calculator. And we find out that our final velocity is 25.48 meters per second. Okay, so that's the first one. Now, the second one, we're going to go ahead and come up with the equation we need for that. Now, how far? That's a displacement. Now, let's see if we can have an equation that has all those things. Now, it doesn't have to be that we're solving for what is just solved for in your equation already. We might have to rearrange. But for this particular one, it's actually there still. So distance or displacement equals v sub naught t plus 1/2 at squared. Okay, so if I look at this and make sense of it, my initial velocity is 0, so that zeroes this part out. And I'm left with 1/2 at squared. Okay, 1/2 at squared is your free fall equation. You're going to see it a lot. So let's go ahead and plug that stuff in there. So 1/2 a, in this case, is 4.9. A lot of times, if we're doing that 10 number, that just turns it to 5. It's real easy. And our t is 2.6, and we're going to have to square that. Okay, so 4.9 times 2.6 squared gives us a total displacement of 33.124 meters. And that's what your work should look like. All right. You need to solve this one for Tuesday. Go ahead and look at it. If for some reason you can't figure out what is written there, just holler at me, stop in and say, hey, Mr. Brewer, I can't see what you got there. But that's the problem you have for tomorrow. Good luck.